Hi, everyone. Thank you so much for joining us live today or watching the recording on demand afterwards. My name is Morgan Costel. I'm a customer success manager here at Cure. I work with engineering teams day to day, helping them get the most out of QVScribe, working through the challenges that come up when they're trying to bring real consistency to requirements across a complex program. And with me today is Martin Fay, our product manager. Martin works directly with customers to understand where things are breaking down and what needs to be true at a systems level to actually fix them. So, here's a bit of what's been on both of our minds lately. In almost every team we talk to right now, AI is already in the room. Engineers are using Copilot, ChatGPT, and other tools to draft requirements, rewrite them, generate test cases, documentation, sometimes even code. And a lot of the time, that has sort of happened organically. No one made a formal decision, someone just tried it and it worked. And now everyone seems to be using it. And honestly, the appeal is completely understandable. Those tools are genuinely useful. But what we're hearing more and more isn't, should we use AI for this? It's, okay, but how do we know if what it produced is actually right? And those are two very different problems. Because what we're also seeing is that in a lot of programs, this is sort of just happening without any real structure around it. And what feels like a win in the individual level becomes a risk at the program level, sometimes even discovered mid program, when you've got suddenly hundreds of requirements that need to be traced, validated, and corrected. And at that point, it's no longer a quality problem, it's a schedule and compliance problem. So, Martin, I'd like to start with you today because before we get into how to structure this well, I think it's really worth being honest about why AI is so appealing in the first place. What are you hearing from teams?
Yeah, well, the economics of authoring changed dramatically. Tasks that previously could take hours, drafting requirements or restructuring them, generating test cases, that can now happen in minutes. Um, and that goes beyond just doing the same work faster. With AI, teams can produce more and at a level of completeness that just wasn't possible previously. So beyond mere efficiency, there's a genuine shift in throughput. What doesn't change uh, is the fundamentals of what downstream teams need from requirements. So test teams, design teams, verification processes, these all still need requirements that are clear, unambiguous, traceable. And AI does not change that standard. AI does change how fast you can produce something that looks like it meets the standard.
Right, and that gap is exactly where programs tend to get into trouble. It's almost harder to catch because it looks so good on the surface. There was a post at the professional report a few years back, specifically on requirements management, and it showed that nearly 10% of project cost increases tie back to poor requirements. Nearly half of unsuccessful projects fail to meet their goals because of them, and more than half of all engineering errors originate right there in the requirements. And the truth is, AI doesn't change any of that. It just means you can accumulate those problems a lot faster than before. So, when you think about why requirements specifically are where this tends to break down, what do you think is the underlying reason?
Yeah, well, requirements are the first place where intent becomes language. So, everything downstream, design, testing, verification, is built on that foundation. So any ambiguity at that foundational requirements layer does not stay contained. It spreads, and the more it spreads, the more expensive it becomes to correct. And that becomes particularly intense with cross-domain programs. So say you've got, software, mechanical, regulatory teams, and so on, all working from the same requirement set. Um, there's a team in aerospace we work with, and they describe requirements as the interface. And that boundary between requirements and systems engineering, that's where the risk lives. A team, or sorry, a term meaning one thing to a software developer might mean something else to a mechanical engineer. There's a gap in understanding. So with AI generating content at speed and simultaneously across domains, um, those gaps multiply rapidly.
Yeah, and we hear this a lot of time from teams in those kind of programs that the requirements are like the connective tissue between all of those different disciplines. And when that particular layer is unclear, everything downstream is making their own interpretation. And by the time those interpretations actually surface, you're already deep into a program with a lot riding on it. And that's really the thing. Unclear requirements don't just create extra work, they make it impossible for everyone downstream to be working from the same understanding. And when you've got those multiple teams, multiple domains, and then that layer of AI generating content at a higher speed than ever before,
Organizations have felt this pain in some form. The challenge is that AI has transformed the scale of the problem, much faster than most oversight processes have been able to respond. Um, What's also changing is that the pain is emerging earlier in programs than it used to. I think teams used to feel requirements problems in testing, maybe at a review gate, and now they're feeling them sooner because AI is generating more content earlier, and the gaps are surfacing faster. So there's this cruel irony where the window to catch and fix things is shrinking, not expanding, even though the tools feel more capable.
and I think that's the core of it. The scale has changed before the structure had time to catch up. So, Martin, let's take some time to get into what that actually looks like.
Yeah, we can think of AI as a potent accelerant. It's not a magic fixer. It's also not a risk in itself. It's an accelerant. It will amplify whatever process is embedded in, both the good and the bad. So if you've got strong foundations, clear standards, consistent terminology, structured review, AI makes all that faster. It'll compound whatever discipline you've already built. But if you've got weaknesses in the process, ambiguous language, ad hoc reviews, no shared standard, AI compounds those too, and it does it faster than any team can keep up with manually. Um, because AI does not really distinguish between good versus bad process. Whatever you give it, it will accelerate. So a process that was weak before AI will only deteriorate faster with AI, and I think that's the part that some teams don't see coming.
Yeah, and honestly, I think that's probably the thing I hear most from teams because the misconception that we run into the most often is that AI is just gonna fix all the problems. Teams think if we use AI to generate requirements, they'll be better, more complete, more consistent, and sometimes that can be true, but if the underlying process isn't strong to start with, AI just gets you the same problems faster and a lot more of them.
Yeah, and it's worth noting that, in talking about AI, it's not just requirements authoring. Teams are using AI to generate test cases from requirements or documentation from design decisions, even code directly from specs. So ambiguity in the requirements propagates through every downstream artifact. And so the blast radius of a poorly written requirement becomes much larger when AI spans a whole chain of artifacts.
Right. And the teams that are actually getting the benefit without that risk piling up aren't just prompting AI and accepting whatever just comes back to them. They're asking questions like what standard does this need to meet and who's actually accountable for that check. And I think that's really the distinction of using AI versus actually governing it.
Yeah, and the difference there isn't really so much the AI tools themselves, it's the process around them. The teams that are using AI most effectively have generally already done the hard work of defining what good looks like. They've encoded standards, prescribed quality thresholds, structured review. So slotting AI into a process like that, can really make it faster. But teams using AI blindly are essentially asking AI to define good for them. And that's where the risk can really accumulate.
And the tricky thing is that it doesn't feel like it's accumulating. That's what makes it super hard to catch. AI generated requirements, they look structured. They use the right language. They pass surface level reviews sometimes. So the team just keeps on moving on, and then they find that something downstream just doesn't add up. Maybe it's a test case that can't be written because the requirement's ambiguous, or a supplier interprets something differently than intended, or maybe even possibly at a review gates, a gap is surfaced that no one saw coming. We actually had a team in the defense space to describe it almost exactly that way, where they knew that there were issues, but the document looked complete, so they just kept moving on. And then by the time they actually felt the impact, they were deep into design and created a massive headache for themselves.
Yeah, that points to a common misconception that AI outputs don't need the same level of review as human authored requirements, and of course that's exactly backwards. The very fact that AI output can look so convincing is precisely why it needs objective evaluation. Looking right is not a standard that can be defended in a regulatory environment.
And yet, the pushback that we sometimes still hear is that standards can slow things down. But the teams that we do work with who have actually gotten this right would tell you it's the complete opposite. The structure is what lets them move fast with confidence. Without it, you're not actually moving fast. That's the illusion of moving fast. Instead, you're just deferring the cost. So, Martin, what actually needs to change about how teams are thinking about this?
Well, I guess it's an opportunity to shift the mental model here. I mean, it's easy for teams to think of AI as a writing tool. But I think a more instructive mental model, particularly from a systems engineering perspective, is to think of AI as a generation engine. And for reliable, robust operation, every generation engine needs a separate evaluation engine running alongside it. Not the same system, a separate independent system, um, and one that can keep pace with the speed of generation.
I want to make sure we get into what that evaluation engine that you're talking about actually needs to look like, because I think that's exactly where a lot of the teams have that wrong mental model, as you said, about how to solve it. Do you mind just kind of going into that a little bit more?
Sure, yeah. For a lot of teams, the instinct is to use AI to check AI, have the model review its own output or bring in a second model as a validator. And we can see why that feels right. It's automated, it's fast, and it seems like it closes the loop. It, but that doesn't actually solve the problem because large language models are probabilistic. They predict outputs, but they do not apply rules. And that leads to two problems. First, evaluating a given requirement more than once might produce different results each time. Um, Second, and more importantly, you can't fully explain why a particular output was approved or rejected. There's no audit trail that holds up. And of course, in regulated environments, that does not fly. You have to be able to show, that a requirement was evaluated against a defined standard, that this standard was applied consistently, that there's a record of it. Um, that's what deterministic evaluation provides. Rules that are explicit, repeatable, and traceable. Same input, same output every time. And with a clear rationale attached.
Okay, so that makes sense, but what exactly does a deterministic check actually catch that an AI wouldn't?
Yeah, imagine a requirement that says the system shall respond quickly to user input. All right, so an AI validator might look at that and say, yep, that is a well-formed requirement. It has a subject, a verb, an imperative. It passes a structural check. Um, a deterministic evaluation engine might flag the word quickly, as a non-specific temporal word. So it flags the absence of a measurable threshold. And might also produce a comparatively low score, say a 2 out of 5, and with a specific rationale attached to every issue that was flagged. Um, and it would do that repeatedly, like the same way every time, no matter who or what, did the authoring. So um, that's the difference. AI gives you plausible, deterministic evaluation gives you defensible. And that's what AI on guardrails really means. Harnessing AI speed while ensuring that every suggestion is grounded in a standard before it moves forward.
I see. And I think that distinction matters even beyond the technical. It's not about catching problems in the moment. It's about being able to prove that you caught them. Especially in those regulated industries, that record is part of the deliverable. And I want to be clear, this does not replace a human reviewer. It just changes what they're spending their time on. Instead of reading through every requirement trying to spot ambiguity, which is exhausting and inconsistent, they're looking at scored, flagged sets and making judgment calls on things that actually need judgment. That is a much better use of an experienced engineer's time.
Yeah, that's true. I mean, a human reviewer, can ask a clarifying question. AI doesn't. It will work with what it's given. So if the requirement is ambiguous, the AI generated test case derived from that requirement reflects that ambiguity, and maybe no one flags it because the generation looked clean. Um, Deterministic evaluation catches that before it spreads.
Yeah, and most teams are bridging this gap manually. Someone reads through the AI output, checks it against a standards document, if one actually even exists, and then they make a judgment call. It's really, I think, a bit more of a patch than a process. Your most experienced engineers become the last line of defense, and two of them reviewing the exact same requirement will catch completely different things. And more importantly, that doesn't scale. And it gives back all that speed that AI was supposed to provide in the first place.
Yeah, yeah. Manual review processes were designed around manual authoring speeds, human authoring speeds. So, say a team might produce requirements over days, even weeks, and reviewers have time to catch up. Uh, and that model just breaks, when AI is generating at machine speed. The bottleneck shifts. Authoring, is no longer the constraint. Evaluation is. And if the evaluation layer can't keep pace, you end up with this backlog of unvalidated AI-generated content that grows faster than any team can manually review. So the bottleneck, does not disappear; it just moves. So the evaluation layer has to match the pace of generation. Automated, deterministic, and continuous. So not periodic audits, not end of phase reviews. Continuous, and still with a record attached at every step.
And honestly, that can be a huge mindset shift, going from reviewing requirements and milestones or over to having them continuously evaluated as they're being written. We're working with a software company that has built this into their policy already. The AI can't move to the next step until the requirements meet a defined standard. No trail, no next step. And those guardrails aren't arbitrary. They're built on standards their team already works from, their own terminology, and their own bar for what good looks like. That right there is what makes it something that you can actually stand behind. So, Martin, when that evaluation layer is in place, what can change downstream?
Well, what changes is that testing becomes validation, rather than discovery of hidden issues. So when requirements are clear and traceable going in, test cases can be written with confidence, and teams aren't spending time in test figuring out what the requirement actually meant. They already know, and there's a record to point to. And milestone readiness becomes a defensible signal, rather than just a judgment call. And we're hearing this across industries, medical, defense, energy. Um, Teams are using quality scores as a gate signal at every meaningful handoff point across the life cycle, from proposal all the way through delivery. And in practice, this might look like a dashboard, not a spreadsheet someone compiled, but a live picture of quality across every active document. So score averages and distributions, requirements that are flagged as high risk, trends in quality since the last snapshot. So a program manager can look at that, before a gate review and see exactly where the risks are, before they walk into the room. And that fosters a fundamentally richer conversation than I think most teams are having at those gate reviews today.
So I think this is probably a good point to talk a bit more about what good actually looks like in practice, because there are four things that we do consistently see kind of working together. The first piece is those encoded standards, things like the Encozy guide for writing requirements or EARS syntax patterns built into an evaluation layer that every author can work from, not sitting somewhere that people maybe reference occasionally. The second is that objective scoring piece. And importantly, that score will mean the exact same thing, whether you're the most experienced system engineer or someone just 2 months into the job.
Yeah, and that consistency is what makes the score scalable. With a shared objective standard, you can compare quality across teams and programs over time. And I guess that brings us to a third element, milestone readiness signals. So not just are the requirements written, but are they ready? A quantifiable answer to that question, from proposal through delivery. And most gate reviews today, I think, come down to someone making a judgment call about readiness. And that judgment depends on who's in the room, what they've seen before, how much pressure the program may be under. Uh, an objective quality signal removes that variability. The standard is the standard, regardless of who's reviewing it or what the schedule pressure might happen to look like.
And what makes all of that possible is that fourth and final piece, which is continuous evaluation. Not something you do at a particular milestone, but part of the authoring workflow itself. When that feedback loop is tight, issues get caught earlier when they're still cheap to fix.
Yeah, yeah, and I guess together those four things make quality visible at the program level, not just the document level. So, just by way of example, there's a medical device company we work with, managing requirements quality as a corporate standard, across 15 operating units. So, leadership can ask, where are we across every active program and get a consistent, comparable answer. That's a far more encompassing visibility than most organizations have today.
And that visibility changes things at the author level too. When the authors are able to get the real-time feedback as they write, not just at a review meeting a couple weeks down the road, the iteration cycle compresses significantly. And because that standard is consistent, it changes how teams onboard as well. One team we work with put it really well. They said a way to tell a new systems engineer what a good requirement looks like, I think, is essential. That is exactly what encoded standards or an objective scoring can do. Everyone is now working from the same playbook from day one, not dependent on whoever happens to review their work at that time. And also, a bonus, when senior engineers retire, that knowledge doesn't just walk out the door with them. It's in the system, not in their heads.
Yeah, that's requirements quality as infrastructure, not just a writing aid, the foundation that AI on guardrails is built on. Um, And as AI becomes ever more embedded in engineering workflows, requirements level oversight becomes the first layer of organizational defense. Everything else, traceability, compliance, downstream artifact quality depends on getting this layer right.
So, I'd like to now take some time to talk a little bit about how misalignment actually shows up in day to day, because it can look sort of different depending on where you sit in the process and what you do. For the people who are writing requirements, it's clarification requests that just keep on coming back. Maybe you used AI to move fast, but reviewers are still finding ambiguity and rewrites are happening late when that context has already shifted and the cost is a lot higher. And the really frustrating part is that the requirement looked fine when it was written. The AI produced something clean, but clean is not the same as clear. For the people validating, it's inconsistency that's super hard to pin down. Terminology used differently across documents or even in the same document. Coverage gaps you only discover because something downstream just didn't make sense. In regulated environments, that goes even further. Requirements that passed every internal review, but then introduced risk in a submission. Or maybe systems built exactly to spec, but the spec didn't fully capture the intent. Those are the hardest to defend. And for whoever is accountable for delivery, it's a schedule risk. Milestones slip because the requirements weren't actually ready, even though they looked complete. By the time it surfaces at that level, there's not a lot you can do. So, Martin, from your perspective, from the product's perspective, what version of this is the hardest to recover from?
Yeah, hardest is when there's no record of how things got to where they are. So, requirements get written, a review happens, the document moves forward, but, say the review was informal, the standard was implicit, there's no baseline, no quality score, no record of what was evaluated and when. So when something surfaces downstream, there's no trail to follow. You can't determine where the problem first emerged, how far it's traveled, what choices were made on top of it. And so the investigation becomes as costly as the fix. I think it's also worth noting that the regulatory environment is shifting. So in some government and regulatory contexts, AI usage that was previously restricted or even just plain forbidden is now becoming permissible. Um, that's a real opportunity. It also changes the risk profile significantly. With AI being permitted to touch more of the requirements lifecycle, that oversight layer becomes all the more critical. And so the teams that have already built that infrastructure, encoded standards, continuous evaluation, audit trails, those teams will be able to take advantage of that AI shift, safely. The teams that haven't are going to find that the expanded permission for AI also creates expanded exposure.
So listen, I could talk about this for so much longer, but we are at the 30-minute mark. So I
Hmm.
think it's kind of time to try to wrap this up a little bit. What it all comes down to is that AI is an accelerant. It speeds up whatever process it's running on, good and bad equally. And honestly, weak processes don't just stay weak, they deteriorate faster. So the question we keep coming back to isn't whether or not to use AI, it's whether the foundation is strong enough to actually run on it. And that starts with requirements.
Yeah, and that foundation has to be built before the volume scales. Once AI is generating at full speed, and the structure is not there, catching up is much harder than building it right, at the outset.
Yeah, and I think that two non-negotiables follow from that. Generation and evaluation just have to be separate. The same system can't objectively evaluate its own input. You need an independent, deterministic layer that runs at the same speed, but then also leaves a record at every step. And I think you also need that visibility layer. When you can score quality continuously and surface it at the program level, leadership has what they need to make good decisions before they walk into the room and not after. And what sort of ties all of this together is the truth that AI didn't create this problem. It just inherited it and has scaled it. And that's exactly why the guardrails just have to come first. So before we move on to questions, is there anything else you want to add to the discussion, Martin?
Just that, this is the direction that things are heading. Teams are building these habits now, or that are building these habits now are going to be in a much stronger position as AI becomes even more deeply embedded in engineering workflows. And once requirements are high quality and being evaluated continuously, you can extend that oversight across the rest of the artifact ecosystem. So design specs, verification criteria, all of it. And we're already seeing teams do this. It's a natural next step. Once the foundation is there, traceability can evolve from a compliance record to a predictive tool. For impact analysis, change intelligence. And the audit trail that might have begun with requirements becomes a thread running through the whole process. So I think what that eventually looks like is, AI operating at speed, across every stage of the life cycle. And teams are starting to move in that direction. And so it's not about slowing AI down. It's about making sure the foundation is strong enough that AI can run on it safely. Speed is easy, at least at first. Defensible velocity, that's the hard part. And that's also where the leverage is, not just better requirements, but a life cycle where AI can operate at speed, because the guardrails are already in place.
Love that. I, I think it is time for questions since we don't have that much time left, but I'd love to dig into that more. But yeah, I'll just open it up to Yana to point out any questions now.
Thanks, guys. We did get a few questions coming in, so I just want to say to everyone that's been asking them, thank you very much. If we don't get them, I've been copying them over, and I'll make sure that somebody from the QA team reaches out after the webinar and has a conversation. So the first one that came through is this person or this team were already using Copilot to help write requirements. How do we know if what it's producing is actually meeting our standards without reviewing everything manually?
Yeah, that question makes sense. And it's something that we do hear often from our customers and other folks we talk to. And it's probably honestly the most common thing we hear right now. The honest answer is that most teams don't really know. Someone reviewed it, it looked okay, moved forward, and that works until it doesn't, until somebody pushes back, a test fails, and somebody wants to try to prove that against whatever standard you have. And the shift we see in teams that do get this right and moving the bar a little bit is that the record doesn't exist unless you have something doing that objective look at it. And that's exactly what QB does. So it gives you that objective record grounded in your own standards. So you're not just hoping that the output is right. And if you do want to see what that looks like in practice, just reach out either by the email that Jan is going to share at the end or the booking link I shared. We'd be more than happy to walk you through it.
Perfect. And that kind of leads in nicely with the second question we had. So, you've obviously talked a lot about the generation, the evaluation, and needing those to be separate. But when it comes to practice, how does one actually build that into a team's workflow without adding that extra layer of work or overhead?
Yeah, I think being worried about overhead is it's a very understandable concern. And I think it's true. Manual evaluation, feels heavy, because it is. Someone has to read through everything, apply their judgment, document what they found. Um, as the key described is built around the idea that evaluation runs continuously, as requirements are being written or as they're being revised. So the overhead essentially can disappear into the workflow. And so with that process in place, the review meeting becomes about decisions, not discovering issues for the first time.
Yeah, and I do want to add from a workflow perspective, it's less about adding a step and more about shifting to when that step happens. Instead of a big review at the end of a phase, you're getting that continuous feedback I've mentioned throughout the authoring. So then by the time the requirements are ready to go to review, the easy stuff's already taken care of, and the reviewers are spending their time on substance, not cleanup. That's, in my opinion, actually less overhead and not more.
Perfect. And I know we're kind of running out of time here, so I'm going to try to squeeze one or two more questions in. But feel free to email me after if anything comes up. The next one is you've mentioned the regulatory environment is shifting and AI is becoming more permissible in some contexts where it wasn't before. Could you say a bit more about that when it comes to the practicality in teams?
Yeah, I guess it's worth starting with kind of sort of underlying, pre-existing observation that, even a perfectly generated requirement, faces kind of a trust problem with certification authorities. That has nothing to do with how good the output is, so say for aerospace, so FAA or the EASA, you know, they need to be able to inspect the provenance of an artifact, where it came from, what standard it was evaluated against, who reviewed it, and when. So a black box, an AI black box that produces plausible requirements, does not satisfy that, even if the outputs are good. Um, So that's where, as you described, has snapshots and timelines that create, that kind of traceable record. Every evaluation and score, tracked over time. So the audit trail isn't just good practice; it's actually a strategy for certification. So this separation of generation from evaluation, a traceable record at every step. Ultimately, those exist as much for the authority that has to sign off on the work as the engineer doing the work.
And I also think that that just reframes the whole conversation around AI in those regulated industries. I'll say again, more than happy to talk through what that would look like in your specific context in the particular environment that you're in. So just reach out to us and happy to chat about that a bit more.
Perfect. And I'm going to squeeze this one in because I personally have heard this a lot. And so I wanted to kind of push it through while I can. With a lot of senior engineers retiring in the next few years and a lot of institutional knowledge leaving organizations and also is the industry itself, how does requirement quality tooling actually help support that?
Yeah, so I'll pop in and answer this one a little bit. And because I've actually seen this happen in a couple of organizations I've worked with, and it can be pretty painful. Like you said, a senior engineer retires or moves on, and then suddenly the team has no idea what was going on or why certain requirements were written the way they were. They can't tell if something's actually a problem or if there was some sort of reason or rationale for why it was written away. And also, then review cycles just slow down because nobody has the context. If they were using AI to also generate new requirements in that environment, AI has even less context than the team does, so it can just really accelerate the confusion there.
Yeah, I guess, yeah. The act of encoding standards and building a quality baseline is kind of a knowledge capture exercise in disguise. So every decision about what gets flagged, what gets approved, so on, that's institutional knowledge that's being made explicit. And so I guess a team that starts this, while their senior engineers are still around, are doing a service to themselves. They're essentially doing a knowledge transfer that persists um, after those senior engineers leave. Um, and of course, the standard doesn't change, or it shouldn't, with people coming and going. The standard should get refined over time. Um, Become something that the whole team works from, and not something that lives with just one person or one senior engineer.
Awesome. Thank you guys so much. I did leave my email here. I know that we've run out of time. We actually went over time, which is always great to have personally. I like the sound bites, but I did leave my information here. So if there's any other questions that come up post webinar or with sharing the recording, if you want to connect or if there's any suggestions on topics that you'd like us to look into, please do not hesitate to reach out to me directly. As I said, that's my email. I'll also include it in the email that I send out tomorrow. I'm going to quickly stop sharing so I can see everyone's face again. But yeah, so I just wanted to say thank you again for taking the time, and we really appreciate you sitting in and joining us in this first kind of discussion that we're having. Appreciate it.